actually, I think that I have two sessions today, and the first one should be about automating the data ingestion, while the one about new card and slicer visuals is in 2 hours. So I'm happy to do that then. And now I think let's focus on automating the data ingestion into Power BI and exploring that. So yeah, today during this session for the next 45 minutes, we're going to talk about how you can help yourself with some difficult data formats and automate some of the data download into Power BI with the use of custom Power Query functions. So in very simple words, just reusing your mQuery code that you have either wrote yourself or created using all the user interface. Great. So let's get into it. And before we begin, let me just briefly introduce myself. So my name is Greg Strzymiński. Feel free to call me just Greg, because my full name is a bit difficult to pronounce. I work in a management consulting company called Kearney as a senior BI developer, and I specialize mainly in Power BI, but also SQL, Azure, like Azure Databricks, Data Factory, and so on. But my trump card is definitely Power BI and DAX. Where can you find me? You can find me on my YouTube channel called Greg Works Power BI. I have all the details here on the screen. You can also connect with me via my LinkedIn or Sessionize account. You can see all the details at the screen right now. I will be super happy to have your subscription in YouTube. If you are considering to explore your career in data-related fields, especially Power BI, then I'm sure you will find some relevant videos in this YouTube channel for you that will help you to get through the interviews better. Okay, with that in mind, let's jump into the agenda of this session. So we will be talking first about what the custom functions in Power Query are in general, so that you understand the necessary theory to get ahead with the practice part. Then we will jump into the use cases for Power Query custom functions. So how do you spot an opportunity for using this amazing feature that has a lot of power within it? There are some very specific use cases that are super easy to spot, and that should immediately pull a flag in your head that points towards the custom functions in Power Query. We will also have a live demo when I will show you how to create a custom function from your already created Power Query code in a nutshell, and also how to debug it in case there are any mistakes and what to do in such a scenario. So we will have an error handling part as well. And then as the final point in the agenda of this session, we will talk about the limitations and considerations behind this feature. So just some red flags, false threats to keep in mind to not get you into a difficult situation with the custom functions. Okay, cool. And with that, the learning agenda is that after this 45 minutes, you should be able to recognize when to use the Power Query custom functions, how to build them to handle some specific scenarios, and also you should be able to know what to do in case your custom functions are returning an error, you are having some trouble with them, how to basically get around that. Okay, cool. Let's get into the first point in the agenda, that is what are the Power Query custom functions in principle. So before we go to the definition of a Power Query custom function, so a function within Power Query, the one that is user built by you, by the developer, let's first see what a function actually is. So a function, just like you've seen in math classes, for example, is just a transformation that we do on something. So this is the easiest example. You just take some input that is x, you apply some function to it. That could be either multiplying it times 2 or doing something else, like a quadratic function or a derivative. And from the input and the relevant transformation, you get the outcome. Basically, that is something else. Of course, in terms of Power Query custom functions and the potential to automate some of our data ingestion, we will not always be willing to do a function like multiplying just one number times 2. The most impactful use case would be taking the input that is usually a table or a table-like format, and then transforming it into a more Power BI-friendly format, doing something with that. So our input would basically usually rather be a table in terms and speaking of Power Query custom functions. Cool. So for a function to work, we need 3 parts. We need the input, we need the function source transformation, and we need the outcome. This can be as easy as a quadratic function, so y equals x squared. And once we have defined our transformation, the goal, of course, to maximize the value from this function is to just go in a loop over a number of inputs, generally speaking, and apply the same function to them. So this can be as easy as going over in a loop over the numbers from -100 to 100 and doing a quadratic function, so x squared over all of them. But for Power Query, we would likely want to go over a number of tables, do some transformation on each of them, and then combine all of them together. So when we now define a custom function in Power Query language, we will be operating on a different terms. So the specific words are a bit different. As the input, so the x, it will score a parameter in custom functions Power Query, and very similarly in any other functions that you create in any programming language. So we have a parameter. The function is the transformation, so what we are doing with this parameter, likely a table in this case that we will be focusing on during this session. And as a result, you get some kind of output that can also be a table. It can be a scalar value, so just a single number or single text, but likely also a table. Great. So now, moving towards the second point in agenda, the use cases for custom functions in Power Query. The most generally defined use case would be something like that. So we use the custom functions in Power Query to transform multiple files in the same format at once in the same way and then consolidate them. So just go in a loop over a number of inputs that can be either CSV files in your SharePoint folder or some embedded JSON tables in an API. Then you want to apply the same transformation to all of them and consolidate them, so put them in one table, one Power Query table, ultimately in Power BI. So from this definition, we have 3 key points that need to be that we need to have in order for the Power Query custom functions to work correctly. So first, we need multiple files because it only makes sense to create a function and apply it over multiple inputs if we have multiple inputs. So we need to have more than one file that is in the same format, or otherwise the transformation might actually fail. So we need the files to be somehow consistent in terms of the column names, number of columns, the content of these columns, and so on. And also we must want to transform them in the same way, so that for each of the inputs, we apply the same transformation, and then we get a result that is just one table. And that is the use case from which you usually get the most value and time savings in Power Query custom functions. So yeah, for this to work, we need to have the files in a consistent format, like just column names, column headers, and so on, and available for Power BI to ingest. So either a SharePoint for the local network drive somewhere in a SQL server that you can connect to, or an API that you have access to. It's nice that for the usual case for such Power Query functions, you also the most frequent case is that you have some extracted files in your SharePoint folder or network drive, like you have the same sales file for January, February, and March, and so on, and maybe for 2 years back, somewhere in a SharePoint folder extracted from a source system like SAP Dynamics, Business Central, and so on. Someone is doing maybe some manual transformations on this, so you cannot really connect directly to the data source. But still you want to use this file and this input somehow. So another nice to have is that it's not super possible to get access to the actual data source in case you are using extracts, and we will have that example in a moment. Also, you need the insights quickly. That's an advantage, and that's a point when you should use the custom function, because it's really quick to build, like really quick. And also there are some manual steps included in the data transformation after extracting from the data source. So maybe some data analyst or data quality officer might be doing some quality checks and adjusting some points in the data after it is extracted. Some manual amendments or controls are being done. That might be something that's not necessarily possible to automate at this point. It just needs a human to do it and sense check the data. So if you have something like that, it's also a use case for the custom functions. Okay, and let's see some of the 3 popular use cases. So the first one is something that I've already told you, a very popular case that you can face in your company or for your clients. I have faced it a number of times. So you have some kind of manual extracts from a source system from somewhere, stored as Excels or CSVs in the SharePoint of your team, of your company, in a local network drive, something like that. They are used by the team or by some analysts for some analysis in Excel or so on. And basically the files are just there in your folder. You cannot access the data source directly, which could be a SQL Server, it could be SAP Dynamics, and so on. Another frequent use case is that you get periodically some data sent from another division, another team, another vendor of yours maybe, over email periodically, and this cannot be also automated. So for example, your vendor that does some work for you sends you monthly billing reports for how much hours are they charging over an email, like on the last day of the given month, and you need to use that data. So this will also ultimately generate a number of files that should be same structured and you can use. And also a very popular use case, you have the same data across multiple Excel worksheets. It's just for a different entity, maybe for a different country in each worksheet. So country A in the first worksheet, country B in the next worksheet, and so on. But generally the format is the same. It's always the sales data, marketing data, structured in the same way, basically. So these are the 3 very popular use cases that are immediate yeses and flags that you should consider Power Query custom functions to ingest this data into Power BI if you want to leverage this data in your Power BI dashboard and report ultimately. So if you see anything similar to this, then immediately consider Power Query custom functions, as this solution will be refreshing automatically, will be relatively easy to set up and maintain as well, as long as the inputs maintain consistent between each other and are someone just adds new files, new incremental data to the folder. Okay, and with that, having that all the theory covered, let's actually go to the live demo and see some examples, how you can basically engineer a custom function from scratch. Let's go into that. Okay, I have my Power BI open, and I also have some files prepared. So the first use case is that we have multiple files that correspond to just months in a given year in a folder somewhere in my laptop this time. but you can also have it just as well in a SharePoint of your company, in a network drive, and so on. Basically, you need them anywhere, just in a place that Power BI can access, either as a cloud resource or via a gateway in case of an on-premise resource like a network drive of your company. That also works. Just have these files in a place that Power BI will be able to access from Power BI servers in the best case. So yeah, we have a number of files that are should be in the same format, just in this for different months. Let's see what do we have inside. I have opened the January file, and let me maybe zoom in a bit. So inside you can see a very general and common format for some data extracts. So from row 5 and below, we have some dates, we have countries, units, and revenue. This basically corresponds to the sales of products in a given country and date. So how much do we make on it in monetary value, in revenue, and how many units, so quantity or volume, was actually sold. And we have this data per country and per month. But on top, towards the top of this worksheet, you can see that we have some additional data in there. So this is something that very frequently happens when you export some data from another system that has some data in it. It just adds some timestamps, some additional rows, so that it is actually easier to identify what data are you looking at once you have exported it from the system. So it just helps you to know that, hey, this data that you see in this worksheet is for a given company, for company A, not B. It was created by some user that's called like this, and it was generated on that date. So if you are viewing past that date, it might no longer be up to date, for example. Okay, so we have this data. All the other files are structured in a similar way. So we would like to just ingest all of this into Power BI and see if we can work with that. Cool. So to get into it, I will open Power Query, of course. And now, since all of these files sit in my local laptop, I want to ingest the whole folder of them. I want to first get a list of all the files that I want to loop through and then apply some specific transformations to them. So I will go to New Source. I will go to More and look for something that's called folder. And this is basically a connector to your local folder in your laptop or in your network drive. For this demo, I have all the files and all examples in my local laptop. So this is basically as fast as the transformations can get, since all the files are located in my laptop. If you have your files somewhere in the SharePoint, so online or in a network drive, then I need to just give you a heads up. The Power Query functions will still be relatively fast, but might be a bit slower if your internet connection is of not the greatest quality, because yeah, you basically need to ingest some data from the web. So it will now be the speed of all the transformations and data ingestion will depend on how fast and how good your connection actually is. So let's select the folder, click Connect, and now it will just ask me for the folder which I want to connect to. So I will choose the one that I have just shown you. That's example 1. Let's go for it. Great, and I click Transform Data. It already has showed me some all the files that I have in this folder. If you click Combine and Transform Data, then you might have already seen this. All the codes and functions will be generated automatically, so all the components that you need for the custom function. But we actually want to generate all the components manually, so the parameter, the function, and so on, since we want to see how this is done manually. So let's click just Transform Data. Great. And what we see here is, yeah, basically the list of all 12 inputs that we have in the in our folder. So we will need the list of all the inputs for sure, because we want to go one by one over each of the inputs and do some transformations on it. For that, let's call this query all files, maybe. Great. And now, to define our function, our custom function in the easiest way, we will want to select one of the files. So just go in the January data, maybe, do the transformations that we want on this sample file, and then using these transformations, just create our function that we will be generalized and we will be able to apply over all of the inputs in the loop. Cool. So for that, let's duplicate this query. And let's select our sample file that we will be using to define the transformations. I will go for the January file, but you can go for either of them. Yeah, so we will call this the sample file. And how do I know that we need to stop at this moment and not go any deeper at this point for the january.csv file? This is a binary file, so this is what Power BI sees. I know from this because here in the list of inputs, we also have the content of type binary. So our function needs to actually start the execution and take as the parameter, as the input, exactly this step. So something that's called January.csv or just another month.csv. We cannot go deeper at this point. So this is our sample file. Now to enable Power BI and Power Query to define this as a parameter, we will need to add this as a parameter. So let's do that as well. So we have defined our sample file. Now we need to say, hey, this sample file, the Power BI, is something that you can change for all of the inputs, like row by row. This is the moment where you should, instead of always the January file, for each of the row, you should take the file that is for this given row. So to do that, we need to go to this, we need to have this sample file. We need to create a new parameter. So just click Manage Parameters, create a new one. I will call this par underscore sample file. So par for parameter for the sake of naming convention. We set the type to binary because that's the type of input we have. The default value will be our sample file. So we have created an entity that's a parameter, and we already set the default value to this sample file that we will be using. Great. And now, if we, on the sample file, on the parameter now, create reference, we will actually start doing some transformations on it. So I will already call this query sample file transformation. I'm deliberately using the same wording and nomenclature as Power BI generates by default, so that you can just see how this is similar. And cool, now we have went inside the January file and we see what's inside. So what we would like to do here to get this data into a usable format is that we would first like to maybe get rid of the top 4 rows. That would be ideally the first step, because without it, we can't really use the data. And now we have the first column. We have the column headers as the first rows, so we want to actually use this first row as headers. Perfect. We can also change the type of the data columns. Maybe we can also filter something out. We can filter out Panama, for example. And OK, this is the transformation that we have defined for the sample file for one in one out of 12. So these steps that we have created just by clicking here are the ones that we would like to repeat for each of the inputs. Great. So now we would like to tell Power BI that, hey, we have defined some kind of transformation. Could you just convert it into a function that we can reuse? And yeah, let's do that totally. If you now click right-click on the sample file transformation query, so the one that we are in right now, and click create function, we will be able to do that. Let's call that function, so the main point of this session, let's call it ingest data, for example. And here it also says underneath the name that it asks you for, it says that it takes a parameter that's called sample file. So the file that we start our job with. Great. And now you can see that this actually worked. We have managed to create something that's called a function. You can see that from the fact that the icon here changed, now it's fx and not a table, so a normal query, it's a function. The great thing is that this function will keep updating automatically as you change the steps here in this sample file transformation. So if we would like to maybe filter one more country out, then we just do it in the sample file transformation query, and our function updates automatically. So this is a great feature that enables for quick adjustment of your data, of the transformations in case you need to do something more on your data. And now we have this function. How do we actually run it in a loop? So basically apply it to our files. So what we should do is first, I will delete all the columns that we don't need for now. We will need just the file name, that's sometimes helpful, and the content, so all the files within. And to run your custom function, you go to add column and invoke custom function. That will add a new column for all of the rows that will contain the output of our function, so a table in our specific case. So I click the invoke custom function button. Nice. And now it asks us for the name of the new column. I will just call it data table, since this will disappear in a moment. It also asks you which function would you like to use. For now, we have just one function defined that's called ingest data, but if you would have more functions defined in your Power Query model here, then you would be able to select which one do you want to apply. And as the last step, it asks you, what do you want to use as the input, as the parameter? So what is the file in our specific case? And in our case, the file sits in the content column. It's this binary thing that we can also take a sneak peek at. So we don't want to use the type any, we want to use a column, and our column is called content. So as the parameter, as the input for each of the rows, we want to take the column that's called content. Perfect. Once we have that set up, let's run it and see what happened. Let's take a sneak peek at December, for example, and we can see that there is fortunately some data inside. So it worked. Perfect. We can see that we've got the data. So what to do to consolidate all of this together? We have successfully completed our data transformation, but now we would like to have it all in just in one big table. So you click on this expand button that's in the top right corner of the new column of the result from the Power Query custom function, and you select which columns do you want. For us, we will want all columns, and we can get rid of the content column since we have already extracted it. Great, and now you have all the necessary data actually inside. So you have the date, the country, units, revenue, and we can try actually loading it into the model and see if it works, just to double check that everything went correctly. Cool. And we can see that we have over 4,000 rows. We have 4 countries, nice, and we have all the files as well. So we have 12 files. That's how many we had initially. Perfect. So now you could also say that we kept this column with the file name. So April.csv, January.csv, and so on. Whether you want to keep it or not actually depends on your use case. Sometimes it may be useful to keep this column in the data model that states the name of the file from which your data came from, because oftentimes you can get some unexpected results, data that is just weird, not what you would expect specifically. So if you know from which file this data comes in from, it will be easier to debug it and find the discrepancies basically and fix it probably. But if you are sure that your data is correct, you can just get rid of this column. Because it will just save some space in your model. Okay, perfect. Now let's say that we want to connect to a different folder with the same files, let's say. Maybe instead of having the files in example1 data folder that I have, someone renamed the folder. You need to change the reference to where your Power Query points actually. So how do we reconnect this function to a different folder? That's a very frequent use case as well. So first of all, we can see that our address, the path to the files, is hard-coded in our query. In the all files query, it says that I want all the files to be located in this folder. And it is also hard-coded in the sample file right here. It also says that the path is hard-coded. So ideally, we would not like that to be hard-coded in 10 queries. We would like maybe to create a parameter of it and just use that one instead. So as a best practice, that's what I would recommend you to do. So something that's a SQL Server address, name of the SQL Server database, name of the folder, and path to it in SharePoint or in your local network drive in your laptop. I would recommend to parameterize that. So let's do it right away as well. I will just create a new parameter that I will call parameter underscore file path. Maybe that will be a text, of course, and it will be just the link to my folder in my local laptop. So let's replace wherever we had the old full path, and you instead of this hard-coded path, let's use just the parameter. Perfect, and we want to do the same for the sample file. Cool, and this is really not needed, so I will get rid of that. Okay, so now our function actually could take in two parameters. First would be the name of the file path, and second one would be the folder. So we could run over multiple folders now and run the same transformations if you would like to. But let's actually get back to the case where we want to connect to another folder, to example2 data. So if you have your path to files parameterized like this, then it's enough to change your path to files just in one place in this parameter. So you don't need to run over 10 queries and manually adjust the path there. You can just do it in one place. So I will do it right in here, example2 data. Since we want to connect to a folder that's called example2, maybe someone renamed it, maybe we have some new data there that should be in the same format or so. Cool, we have done that. And let's see how does the data look. And unfortunately, we are facing some errors. So now for the last couple of minutes, we will just go over a troubleshooting session on how to deal with this, basically. We see that we have some errors in our data, unfortunately. And it says we couldn't parse the input provided as a date value. So let's go a few steps back and see which step in the applied steps is the source for errors. Let's go one step back. Here we still see the errors. And okay, now this is something that could help us actually, because we see that the new column that returns us the transformed data from the individual files fails only for one file. It's called March 2019. For the other files, this actually works, and we can see that, well, the input looks correct. There are no errors. So we already get a hint that there is something wrong with one of the files, with the March file. And here it says, when we hover over, when we get a sneak peek, like a tooltip overview of the files inside, of the data inside this query, that an error occurred, okay, and the column date of the table wasn't found. So maybe, for example, someone just changed the name of the date column to time or something like that. Let's see. We go to the March file and see if the date column is there actually. Well, surprisingly, the date column indeed is here. So what happened? We have the date column, but Power Query says that it's not there. So what can we do in this example? One of the best ideas is to use the sample file transformation. So basically, our transformation that we do for all the files, but just for one file at a time, to impersonate the file that is causing us trouble there and see step by step what happens. Because in this view, we cannot see which individual step in the function failed, but there we could. So we want to use the sample file transformation, but as the sample file, we would like to use another file that's not January, but that's March. So let's use that. I will go to the sample file. And instead of January, I will now say that as the sample, I want to use the March file. Perfect. We have that. And now in the sample file transformation, we get basically the function run over a file, but for this March file, we can see what exactly went wrong. So here we see that the column date wasn't found. Let's try to look for the source. So the source is actually that at this point, when we were removing the top 4 rows, apparently in this file, there are just 3 rows at the top. So when we remove 4 rows from the top, we also get rid of the column headers, so the names of the headers that we want to use for our columns. So ultimately, when we promote the headers, well, the names are not what we would expect. We would expect the name of the first column to be date and not the 3rd of October, and so on. So then when we change the type of the columns, we reference the column names somewhere, it fails. Why is that? So, well, in our sample file, in the January file, we had 4 rows in the top. Here we have just 3. This could be a manual error, something just got deleted by mistake, or yeah, it could be just a manual error. So the easiest fix would be just to maybe add 1 row in this file. That's a very quick fix. And now once we refresh it, yeah, we remove top rows, we have everything back in place. So it works. So the challenge that we are facing here is that we had all the inputs, that was okay, but one of the inputs, one of the files was actually in a slightly different format that caused errors to appear, and this is how we can basically deal with it. So we impersonate the sample file with the troublesome file, and then we can go step by step in the transformations and see exactly what went wrong. So this is how you can debug and troubleshoot your Power Query custom functions in case you face any difficulties. Okay, and we have 4 minutes left, so let's get to the conclusion slowly. You can basically use your Power Query custom functions. In examples like shown. So you have a number of same structured inputs, you want to run over them and transform them in a similar manner, just ingest it all into Power BI. So you need to have a number of files in the same format, and you need to want to transform them in the same way. This is when you should use the Power Query custom functions. These are some examples. But just to warn you when it might not be the best idea. So if you have if the data is in a very large volume, you have like hundreds of millions of rows coming from a flat file, it might not be the fastest data ingestion method. It might just take a lot of time and resources to update and ingest all of it into your Power BI report. If your input format is not always consistent, like in the second example that we had, so there were some differences between the files, it's also not always the best idea to use the custom functions, because you will get a lot of errors and it will be just troublesome. The last red flag, a false friend of Power Query custom functions, is that if your data transformations are very compute heavy, then it might also slow down your data loading a lot. And this is not a limitation of the custom functions, but rather of Power Query, that some functions are just slower because they are just difficult to perform. And to name a few, like a pivot or unpivot on a very large data volume might be slow, and also the transpose operation. So these are the three functions that could be slowish potentially. Cool. And now we have ended our demo at just one big table with data, so a flat table format. But we also need to remember that, hey, this is just the start. We have ingested the data in Power Query somehow, but of course there are some best practices forward that we need to remember of. So data ingestion was just the first step. Then we have data modeling, creation of all the measures and visualization. So the next thing after this, after ingesting the data, is of course the star schema. So splitting your data into facts, dimensions, connecting them with the right relationships, and so on. You should always remember that the star schema is the golden standard in Power BI, and it kind of guarantees that the numbers will be what you are expecting. So this is what you should keep in mind. Okay, and with that, I would like to thank you for this session. We have 1 more minute to go, so if there are any questions at this point, then I'm happy to take them. I've seen one question about the differences between the old and new card. Please join my session that will be in 1.5 hours, and I will talk about the new and old card visuals then. So that's in 1.5 hours. Yeah, there's some comment. Great to see some techniques for reusability. Yeah, exactly. This is the reusability where you can actually leverage some of the work that you have done and just apply it over a number of inputs. Okay, cool. So with that, thanks to all the sponsors for this event. They make events such like this happen. You can also fill in the survey to get some feedback to the organizers. And with that, I would like to thank you. And I will have another session on Power BI, new card and slicer visuals in 1.5 hours. If you want to see some of that, that will be a session purely on data visualization. Then please feel free to join and enjoy the rest of the event. And thank you. I will be back in 1.5 hours presenting.